one more example where this is a horizontal surface and this is a vertical sides. These are not touching it. All the surface, they are frictionless surfaces. Over here, there's a 5 kg block connected this other 5 kg block which is hanging vertically by one string, and there's other string, and this is a 15 kg block. Obviously, this side is heavier as compared to this, so this is going to strike the floor with some velocity. We are asked with what velocity this is going to strike the floor. Let's do it once again using laws of motion, and we'll cross-check our answer using conservation of mechanical energy principle. That is on the basis of losses and gains. We'll see that is whether both the answers match or not. So once again, if we use the laws of motion, this side, the force which is acting, that is mg, that is 150 Newton. 15 into g is 10 meter per second square. M into g, weight is 15 into g, that is 150 Newton. This side, 5 into g, that is 50 Newton. We'll not consider its weight because had these two strings they had not been there, this block will remain over here. This block is not moving just because of its weight. Its weight is being balanced by the normal reaction. But whereas these two blocks, they are hanging vertically. So these forces along the forces, these are forces along the forces. These are both the forces, they are along the string. So they will be considered. Whereas this mg is perpendicular to the direction of motion. It will not have any component this way. So that weight, we have done it in laws of motion quite in detail, that this will not be considered. So along the string, 150 Newton is this way, 50 Newton is this way. Net force is 150 minus 50. 100 Newton is the net force, is equal to total mass, 15 plus 5, 20, 20 plus 5, 25, into A comes out to be 4 meter per second square. So A comes out to be 4 meter per second square. So if we have to find the velocity over here, we use v square minus u square is equal to 2as, acceleration is constant, so we can very safely use equation of kinematics. So v square minus 0 square is equal to 2, a is what? 4, s is what? 2, so v comes out to be, that is 4 meter per second. Now let's solve it on the basis of losses and gains. That is, we are going to put losses is equal to gains and we are going to get the answer. So let's call it object number 1, object number 2, body number 3. So we are talking about changes in P1, KE1, kinetic energy 1, potential energy 2, changes in potential 2, changes in kinetic energy 2, changes in potential number 3, kinetic energy 3. Let's start with this. Losses. Potential 1, this goes down. Height reduces, potential reduces. How much? 15 G H is 2. Job is done. I have cancelled it. Now kinetic energy. Over here velocity is 0, over here it strikes with the velocity v. So the velocity has increased, speed has increased, kinetic energy has increased. So there is a gain of kinetic energy. How much? Half into mv square, 15 into v square. Job is done. Over here, potential 2. When this goes over here, we are not taking the case that it strikes with this and falls down. We are not talking about this. This is sufficient length. So there is, the level remains same. There is no loss, no gain of potential energy because there is no change of height. So that's why there is no loss or gain of potential energy. This goes off. Kinetic energy. This is a whole train. These 3 blocks, they are connected by strings, in external strings. So at any instant, whatsoever the velocity of this, the same will be velocity of this, the same will be velocity of this. The velocities, they cannot be different because the strings, they are inextensible. So if this is going to strike with the velocity v, when this is going to strike with the velocity v, initially the velocity was 0, its velocity was 0, so its velocity was also 0. When it has a velocity v, its velocity also rises to v. So it means kinetic energy gain. That is half into 5 into v square. Work done. Potential 3. Now if this goes by 2 meter, this will rise by 2 meter. So there is a gain of potential energy of this. How much? That is 5g gain. It is only changes. What is the height change? It is not from here to here. It is only that is how much height has increased. He has gained the height. So 5 into g into 2. This has gone by 2 meter. This will go up by 2 meter. So gain of height is only 2 meter. So potential gain is changes 5g2. Kinetic 3. Obviously, initially the speed was 0. If it strikes the v, it has also velocity v over here. So kinetic has increased. That is half into 5 into v square. Now losses into gains will put and we'll get the answer. So it is 15 into g is 10 into 2 is equal to, this is half 15v square, half 5v square and half 5v square. So 15 plus 5, 20, 20 plus 5, 25. So it is half 25 v square plus 5 into g into 2. 15 into 2, 30, 30 into 10, 300. This comes over here. Minus 100 is equal to half into 25 into v square. This is 200 is equal to half into 25 v square. This is 400. 425 is equal to v square. This comes out to 16. 16 is equal to v square. So v is equal to 4 meter per second. Once again we get the same answer.